My name is Marius Eriksen, and I work for GRAIL. We detect cancers early when they can be cured. So I would say primarily there's huge data analytics challenges where we're trying to make sense of vast quantities of data. There's a sort of infrastructure component to that as well, so that we want to make sure that we're able to sort of fully utilize and harness cloud computing to do these sorts of analysis of large-scale data sets. So there's a couple of different dimensions. So one is sort of pure data. The sequencers that we have output a lot of data for each sample. It can be upwards of a terabyte of data. And even just moving that data around can be challenging, and storing it can be quite costly. So some of those challenges have required us to do reasonably sophisticated engineering in terms of data storage and data movement and so on. The other side of that coin is again, computation, to be able to analyze these large quantities of data in an efficient way and one that minimizes costs. We make use of cloud computing providers, and we make heavy use of things like the Amazon spot market, and try to be pretty clever about how we schedule our work to be done in order to minimize our costs. I would say a lot of the same. So we're involved in some very large clinical trials, and we're getting more and more data at an accelerating pace. And so there's going to be basically a level up of the same set of challenges. That's one thing. The other thing is that as our analyses are getting more sophisticated, they're also becoming more computationally intensive. And so we need to solve those problems as well. The thing about bioinformatics is that a lot of the standard tooling around bioinformatics has not been built with a sort of efficient architecture in mind. So for example, there's very little attention being paid to the way data flow between different tools, the sort of I/O paths within the tools, and so on and so forth. And there's a lot of efficiencies to be gained potentially by sort of revisiting that at an architectural level. So we use I guess two functional languages. One is R, the language for statistics, which is a functional language, and that's used quite heavily in most of our sort of model building and statistics. The other one is our own proprietary language called Reflow, which is what I gave a talk about today and is now open source. And that is a language that allows us to express these workflow computations at a high level in a way that gives an underlying runtime a lot of freedom to efficiently execute those computations. I think my favorite thing about Scale by the Bay is the diversity of people here. There's people from everything from people who do a lot of online transaction processing to running large websites, to people who do a lot of large-scale data analytics, and sort of people from a wide variety of industries. And it's always nice to get different perspectives.